This is Mr. Anderson for Kellogg Community College. Today we're going to talk about slope-intercept form and point-slope form and how we will write those from a slope and a given point. And then we're going to move on to parallel and perpendicular lines in slope-intercept form. And then finally writing a line in slope-intercept form from 2 points. So we're going to start off with first writing down our two formats here. Let me kind of adjust the screen a little bit so it's there you go, gives me a little more room. Okay, so we're going to start off with the slope-intercept form, which is y equals mx plus b. And m stands for the slope, and b stands for the y-intercept, or where the line crosses the y-axis on the coordinate plane. The point-slope form is y minus y sub 1 is equal to m times the quantity of x minus x sub 1, where x sub 1, y sub 1 is a point on the line. So we're going to first take a look at the slope-intercept form. The slope-intercept form of y equals mx plus b is the format we want the answer in to this question. Find the equation with the given point and slope, where the slope is 2 and the point is 3, 4. To do this, the first thing we would do is plug in our slope, which would be y equals 2x plus b, and then we would have to find the y-intercept. Since the y-intercept was not given to us in the problem, we have to use the point. The point is 3, 4. So we plug the 4 in for the y and a 3 in for the x. And then this gives us a way to solve for b, since all we have left is the letter b. So 4 is equal to 6 plus b. To solve for b, we use an inverse operation, subtract the 6 from both sides. 6 is simplified to 0, so 4 minus 6 is negative 2. Negative 2 is equal to b. Then what we will do is plug this into the final equation, where we now know our slope, which is 2, and we now know our y-intercept, which is negative 2. So the equation in slope-intercept form is a slope of 2 and a start of negative 2, from the equation we have here. Alternatively, the point-slope form is a little bit faster to use, but at the end of it I will show you where it is equivalent to the slope-intercept form. We're going to plug in the point and the slope given in the problem, and that will pretty much finish it up. There's y minus 4, and then there's 2 times x minus 3. So this is the equation in point-slope form, where we have the point and slope. Now, if we take this a little bit further, I wanted to show you that if I distribute the 2, so this is y minus 4 is equal to 2x minus 6, and then I add the 4 to both sides, I'm going to get the same answer as I did over here in the slope-intercept form. So these are equivalent through the algebra that I just showed you, and you may decide, depending on what the book asks for, which format you're going to leave the problem in. So it's either going to be left in slope-intercept form or point-slope form. All right, moving on to the next example here. Okay, so in this case, we're going to do the same process, except the slope it will be a fraction instead of an integer, and we have some negatives here. So let's do the slope-intercept form first, y equals mx plus b. So the first thing I'm going to do is I'm going to plug in my slope, which is going to be 1/2. Then I'm going to plug in my y and my x given in the problem to figure out my y-intercept. So negative 4 is going to be equal to 1/2 times negative 2, which is negative 1, plus b. And the opposite of negative 1 is adding 1 to both sides using our inverse operations. That simplifies to 0. Negative 3 is equal to b. So my end answer to this problem is y equals 1/2 x minus 3, or plus negative 3 if you wish. In point-slope form, we can take my y minus y sub 1 is equal to m times the quantity of x minus x sub 1, and we can plug in my y. So if I plug in the negative 4 into the negative y, that makes y plus 4. My slope is 1/2. If I take my negative 2 and plug it into my, not that one, plug it into that one, my x sub 1, then this is going to be x plus 2. And there's my answer for the point-slope form, and here's my answer for the slope-intercept form. If you distribute this and then add 4, you will get the same answer as you will as the slope-intercept form. All right, so now we're going to move on to 5 more problems here, and 2 of them deal with parallel lines. Now, parallel lines are lines that never intersect. They also have the same slope. So 2 lines that never intersect are denoted by the arrows going in the same direction. These have the same slopes. So for example, if the slope of the first line was positive 1, the slope of this line would also be positive 1. It also goes the same for vertical lines. These have both undefined slopes. And also for horizontal lines, these lines both have 0 slopes. So whether they're positive, negative, or whether they are horizontal or vertical, parallel lines have the same slope. Parallel lines are denoted by 2 forward slashes. Now, what we have to do, and we'll do one and then practice another, is we have to write the slope-intercept equation, which is the y equals mx plus b form. And I choose for this worksheet to not do the point-slope form, just because most of us are going to spend more time doing this on tests, quizzes, and homework. So we are going to write the slope-intercept equation of the line containing the specific point, and it's parallel to the indicated line. Now, a common mistake is to consider that 5 is the slope that we're looking at. But the first thing you need to do is you need to get this y by itself. So I am going to add the 5x to both sides from this 5x here. I'm going to erase that so it doesn't cause confusion. So this 5x, whoops, I'm sorry, has to be subtracted. So I take the 5x minus the 5x from both sides, because 5x minus 5x makes 0. The negative 6y is then equal to, this is 4 minus the positive 5x, this is negative 5x plus 4. So what I did, again, my first step is I need to get my slope. So I'm going to set the y all by itself to figure out what that slope is. Dividing everything by negative 6, this gives me y equals 5/6 minus reduced 2/3. Now this is my slope for my answer. But this is not the y-intercept of my answer. The reason why this is not the y-intercept of my answer, consider this is like the first line. We are now going to use the slope and this point to find the second line. So this corresponds to the original or the first line that we have, but it is not our answer to the problem. We now have to figure out what that second line is by taking the slope and the point given to us in the problem and figuring out where that is. The y-intercepts will be different because if parallel lines never intersect, so it would be impossible for this y-intercept to be in both problems. So what we have to do is kind of like what we did in the previous page. We write down our y equals mx plus b, and we plug in our y's, x's, and slopes to find b, because we need to find the new y-intercept. So the y is 6, the slope is 5/6, the x is 0, and the b is just b. 0 times 5/6 is 0, so 6 is equal to b. There might have been a couple of you realizing that this was a y-intercept, so you might have jumped to the answer of y equals 5/6x plus 6. This is parallel to this line up here. They have different y-intercepts, so they are truly different lines. So that's what we do in these problems. Step 1, get the y by itself by moving everything to the other side. The x and the negative x simplify, and we have negative 2y is equal to negative x plus 3. Divide both sides by negative 2, and this is the way I like to do it, so I can show that the 2's simplify to 1. The negative x over negative 2 is going to make a positive 1/2 x. If you wrote it as x over 2, that won't actually help you when you try to get your slope. Then we have negative 3/2. Now again, this is line number 1. This is not the final answer to the problem because we want to find a line containing a point parallel to the indicated line. So this is our first line, or line number 1. Now what we have to do is find line number 2. So y is equal to mx plus b, so we plug in the slope that we found in our problem, 1/2, and we plug in our y and x. So the y and x given in the problem is going to be 5 is equal to 1/2 times the quantity of 2 plus b. So here we have 5 is equal to 1 plus b, because 1/2 of 2 is 1. Subtract the 1 from both sides, 4 is equal to b. So my answer here is y is equal to 1/2 x plus 4. And there it is. There is my answer to the problem. So here I have 1/2 x minus 3/2, 1/2 x plus 4. This line is parallel to this line. They're parallel because they have the same slope, and they have different y-intercepts, so they do not intersect. So the next two of the three problems we have remaining kind of fit on the same theme, except we're going perpendicular. When we go perpendicular, what we are about to do is we are about to go 90 degrees where they intersect. Now you can easily see that if we have a line that's moving up and a line that's moving down at a 90-degree angle, that one's going to be positive and one's going to be negative. So perpendicular lines are opposite, but that's not all. Two lines that are perpendicular, denoted by the 90-degree angle here, this is the symbol for perpendicular, two lines that are perpendicular are opposite reciprocal slopes of each other. Opposite reciprocal slopes, which means you would take the fraction, flip it on its head, and turn it to its opposite symbol. For example, if the slope was 1/2, then the reciprocal slope that was opposite for making parallel would be -2, because that would be -2 over 1, or just -2. So if you want perpendicular to the slope -3/4, the perpendicular to that would be +4/3. So let's look at the slope-intercept equation containing the point of the indicated line. So the first thing we do, like we did in the last two problems, is get the y by itself. If the homework already has the y by itself, then it saves you a step. But in this problem, we're going to move the 7x to both sides. The 7x is simplified to 0. -2y is equal to -7x plus 1. Then we divide everything by -2. If we do that, we get y equals 7/2 x minus 1/2. And this is our first of our two lines, but it is not the answer, because our answer line has to have the opposite reciprocal slope and possibly a different y-intercept. So let us take a look at the new slope. The new slope is going to be -2/7. Now the point we're going to use is up here, the 0, -3. Again, some of you have skipped to the end already because what we're about to do next is find the y-intercept. Again, look at the point. Some of you might be able to skip ahead. But if you don't see the pattern here, let's plug in our point 0, -3 in for our y and x, and then plug our -2/7 in for the slope, and solve for b. Well, this time 0 is 0, so b is equal to -3. Therefore, y is equal to -2/7 x minus 3. There's our new line. Our original line had an opposite reciprocal slope and different y-intercepts that won't always happen when you work with perpendicular lines as it did with parallel, because they can intersect at the y-intercept, because these lines do intersect. But you'll also notice that a couple of you might have been able to skip ahead, because as you see right here, you have 0, -3, which happens to be on the y-intercept right there. So doing this little step here in this box was a little superfluous if you happen to notice that that was a y-intercept. Let's take a look over here. This is not a y-intercept, so we go through the steps like we did ahead. In fact, this might be a problem where you'd want to pause the video, try it yourself, and then unpause it and see what you get. So we're going to subtract the x from both sides, so -2y is equal to -x plus 3. It is not a mistake that I chose, if you look at the problem above this on the worksheet, the same setup, but I did choose a different point here. So this is going to be +1/2 x minus 3/2. This, again, is our line number 1. And our slope for our new line is going to be -2, because as you see up here, 1/2, the perpendicular of that is -2. That was not chosen willy-nilly. I just wanted to show you that we need to choose the new slope for our new line. So we're going to go to y equals mx plus b for our second line. Plug in our point, -5, slope -2, x is going to also be -2 by coincidence, and then plus b. We're going to solve for b. So -5 equals 4 plus b. Subtract 4 from both sides. Sorry, we ran out of room there. And this gives me an answer of -9 equals b. So my second answer is going to be y equals -2 x minus 9. So there we go. There's our two lines. The first line and second line have opposite reciprocal slopes, so they are perpendicular. They do also happen to have different y-intercepts, which isn't always the same with perpendicular. All right, so moving on to this question here. Write the slope-intercept equation of the line containing these 2 points show all work. Okay, so here we have to get y equals mx plus b. And what we know are 2 points. So the first thing we need to find is our slope, then we need to find our y-intercept. Now, finding our slope can be done with a lesson that we learned 2 sections ago. Our point is y2 minus y1 divided by x2 minus x1, which is a nice way of saying you subtract the y, subtract the x's in the order in which you do it. I'm going to choose 8 minus 4 because those are my y1 and y2 values that I chose in that order. And since I chose 8 minus 4, I'm going to have to go 6 minus a negative 2. 8 minus 4 is 4. 6 minus negative 2 is the same thing as saying 6 plus 2, so 8. My slope is 1/2. So I already have my slope of my problem, y equals 1/2 x plus b. Now my job is to find the y-intercept. Since neither of these points are 0, something, I'm going to have to find the y-intercept by plugging one of these into the problem. Through my 20 years experience teaching math, you're better off plugging in the one with the fewest number of negatives. The smaller numbers aren't necessarily the easier ones to move. The negatives cause the most problems. So plug in the 6 and the 8 to your x and your y. So this gives you 8 equals 1/2 of 6 plus b. Or, as I travel across here, 8 equals 3 plus b, or 5 is equal to b. Therefore, your answer is y equals 1/2 x, which is your slope, 1/2 times your x plus 5. With the slope of 1/2 and the y-intercept of 5, that gives you your equation. And thank you very much for watching.